So in this video we will learn about the transformations, and in this the topic is the vertical stretch. So this is very important topic, the transformation, and I have posted few another videos related to transformation, which is translation and reflections. So to watch that you can just go to the YouTube channel and see the playlist. Now continuing with the vertical stretch, so we will be seeing, so this is the basic graph which we see here, and this is stretched, we can see vertically, so sometimes it becomes narrower than the given one and sometimes it is wider. So this is the vertical stretch. Here we'll be also studying how mapping is and what are the invariant points, or how many invariant points are there. Now what do we actually understand by vertical stretch? So in this, so it is given by the alphabet A, and here the vertical stretch we describe it as, so this is very important statement, and always remember that it should be written in this way only. So this is the standard statement which we use. So vertical stretch by a factor of absolute A about the x-axis. So why do we write absolute? Because if A is, let us say, something positive, let us say 2, in that case this will be not required, it will be just 2 about the x-axis. But if A is, let us say, something negative, -3, so we will take absolute value of -3, which will be 3. So that is why this absolute is must. Whenever we describe any statement, any stretches, any translation, we never write negative here. And if A is negative, let us say if A is -3, so we'll write it is the stretch here, vertical stretch by a factor of -3 absolute value, so which is 3 about the x-axis. And since A is negative, so it's given here, if A is negative, then there is reflection in x-axis. So this is the additional statement which should be written if your A value is negative. If A is positive, then you can ignore the statement, then no need to write this. Now in the vertical stretch, how do the function transforms as? So y is equals to fx, it will be written y is equals to a times fx. So this a value which we defined earlier is the vertical stretch, and here we'll take different cases when a is greater than 1. Next we'll also consider, we'll take the case when a is between 0 and 1, and then we'll also take a is negative. So all the three cases we'll take, so one by one we'll take this. So first we take a is greater than 1. So mapping will be written as, so xy will change as x comma ay. So all the coordinates will be changing in this manner. Number of invariant points will always be your x-intercept. So like in this diagram, we can see that there are two x-intercepts, and it is x and ay, and a value is greater than 1. So whenever the a value is greater than 1, so just remember that the graph is going to become narrower. It will be passing through the x-intercepts, and when we draw this, it will be in the form this way. So x-intercepts are going to be the invariant points. So there are two invariant points. Now we take the example in which y is equals to fx transforms to y is equals to 3 times fx. So first we are supposed to draw the graph of the transformed function, then write the mapping and write the number of invariant points. So to describe the transformation, so first thing, so as we discussed, the set statement for this will be vertical stretch. So a value is 3 here, so this is the a value. So it's positive, so we'll just write vertical stretch by a factor of, since 3 is already positive, we just write 3 about the x-axis. Mapping is always given by the same way, so it is x and ay. So here a is 3, so it is 3y. And how many invariant points? And it is 2 x-intercepts, so we'll write invariant points are 2, which are your x-intercepts. So when we have to draw the graph for this, so again to draw the graph, so we can see that the shape of the graph will be narrower, so it will be in this form. Now again taking the vertical stretch, but here this time the value of a is between 0 and 1. So to describe, we again say vertical stretch by a factor of a. Since a is positive, we are not writing absolute, so a factor of a about x-axis. Mapping will be the same, x comma y will change to x comma ay. And invariant points will be 2 since there are 2 x-intercepts. Now to draw the graph, since a value is between 0 and 1, so when we draw the graph of these kind of functions, so it is first we mark the x-intercepts, which are going to be the invariant points, and here it will be, the shape will be like this. So this will be the shape of the graph. Now taking the example here, so y is equals to fx, so it is transformed to y is equals to 1/2 fx. So we can see here a value is your 1/2. So we again have to draw the graph, then write the mapping, and then write the number of invariant points. So when we describe the transformation, so we can see here, so it's a value is 1/2, so which is positive. So we write vertical stretch by a factor of 1/2 about the x-axis. Mapping is xy and it will change to x comma ay, and a is 1/2, so it will be this. Number of invariant points will be 2 as there are 2 x-intercepts. So when we draw the graph, since a value is 1/2, so just remember that whenever the a value is between 0 and 1, so the graph is going to be the wider one. It will pass through the x-intercepts. So this kind of graph will be there for it. So the next we take y is equals to, again fx transforms to y is equal to afx, but this time a value is negative. So whenever a is negative, so we'll describe it as that there is vertical stretch by a factor of absolute a about x-axis. And also a is negative, so we also have to include here that there will be reflection in the x-axis. So a is negative, so reflection in x-axis. So mapping will be the same, so it is x and ay, and number of invariant points, as the graph has 2 x-intercepts, so it will be 2. And when we draw the graph, so a value is less, so I'm just drawing the graph. It can be wider or it can be narrower, but it will be having this kind of shape. Now we take this example. So in this, y is equals to fx transforms to y is equals to minus 2 fx. So a value, as we see, is minus 2. So we have to describe the transformation. So since a is minus 2, so we'll write vertical stretch by a factor of, so absolute value of minus 2 is 2 about x-axis. So as a is negative, so we will also include reflection in x-axis. So mapping, when we write, so it will be x and minus 2y, and number of invariant points will be 2, which are your x-intercepts. So when we draw the graph of this, so since the value, absolute value for this is 2, so that means the graph will be narrower, but since it is minus, so it's going to be the reflection. So when we draw the graph, so the shape of the graph will be something like this. So it's going to be the narrower graph, and it will be reflection also in the x-axis. Next example we take y is equals to fx, which transforms to y is equals to minus 1/2 fx. So in this, the a value as we see is minus 1/2. So this is the a value. And when you have to describe it, so since a is minus 1/2, so first step we'll write vertical stretch by a factor of 1/2 about x-axis. And there will be reflection in x-axis. So the mapping will be x and minus 1/2 y. Invariant points will be 2, which are your x-intercepts. So when we draw the graph for this, as the value of a, if we take the absolute value, it's 1/2. So whenever the value of a is between 0 and 1, the graph will be wider, and it's minus, so it will be reflection. So this kind of graph will be there. So pause the video and try this question. So it is the same kind of question, just check from the above notes and try it. And once you're done, you can check the answer, which is given in the next slide. So here is the answer. So just check this. If you're not able to get it, refer to the previous concepts once again. And thank you.